Number 3, if you remember part of the test, you had this cost function for manufacturing an X number of bicycles, let's say, per day, and the one that you guys had for your study guide, on your study guide, was, I think, computers per day or something like that. But nevertheless, this C of X represents a cost function, and where the cost is cost for manufacturing X, let's say bicycles in one day, is given to us by this function. And I gave you the interval from 0 to infinity. So what we're going to do is we're just going to try to find the absolute or local max and mins on the interval from 0 to infinity. And first thing we need to do is figure out where this graph is. And I know that this was kind of a sore subject on the test probably because you weren't quite sure how to do what I'm asking you to do. So let's do zoom 6, and we're not going to see really much of anything. When you do zoom 6, you're going back to the standard viewing window from -10 to +10 in both the x and the y directions. Given that, we can't see the graph because it's outside of the range. That's okay. And so, given it's outside of the range and we don't really know where the graph is, we're going to do zoom fit. Okay, zoom fit is right down there at zoom 0, okay, or 10, whichever way you want to look at it. But zoom fit will tell us, or will hopefully give us a better view perspective on this graph. Okay, and so we're going to hit enter. We could have just done zoom 0. And yeah, this is still not a great view of this graph because if you remember, I'm asking for a min or a max, and on the test I said, well, what is the optimum number of bicycles, let's say, that you have to sell to minimize the cost. Okay, well, let's take a look at our window. Our window is still only going from -10 to 10 in the x direction. But if you remember, our domain restrictions here is that x has to be greater than 0. So when x is greater than 0, that we can let our x min be 0, and then our x max. Let's go all the way to 200. I think I've been pretty consistent about letting x max be 200. Because if we sell 200 bicycles in one day, we're going to have a certain cost. Okay, and now the y min also, the cost of manufacturing X number of bicycles is not going to be a negative number, so let's let a y min be 0. And then if you're not really sure about the y max, just go ahead and just leave it as is and hit graph. Okay, so that doesn't really show anything, but we do know though that the function does go back up. If you just keep reducing the y max, let's say we go down to 50,000, okay, keep reducing the y max, we get a better and better view of the graph. So again, we're just adjusting, we're lowering our y max continually, and at 10,000 we finally get down to 10,000 and we see we have a graph in the first quadrant that clearly decreases for a while, and then it looks like it kind of flattens out, and then it increases after a while. And so all we have to do at this point then is to find that low point, and we know how to do that. Second, calculate minimum, 3, and a left bound. If you remember, our x values are going from 0 to 200. So when we do this again, second, calculate minimum, our left bound, we can just let that be 0.1, and that's fine. And then our right bound, the right boundary of our window is 200. So if you keep in mind, 100 would be somewhere right around in here. But just to be safe, just put 150. That's fine. And then I guess just move the cursor over here to the left a little bit, and then hit enter, and you get the numbers that you're looking for. Okay, so you get 50, which is the minimum the x that creates the minimum value for the function, and the minimum value of the function would be 750. Okay, so we get 50 comma 750 for the coordinates of that low point, and if we do everything here, we're going to draw the graph, and the important part of the graph looks kind of like that. We've got our low point at 50 comma 750, and remember the 50 represents the number of bicycles that minimizes the cost, and the cost is the y, or the y values, and so the y value of 750 means that we have an absolute minimum value of $750, and that's the cost. That would be $750 if we continue to use the same analogy, at x equals, or the number of bicycles to be 50. So 50 bicycles minimizes the cost, and that's it. You know, there are no x-intercepts and there are no y-intercepts, and so we've got that. So hopefully that helps. Try number 4 on your own. I'm going to go ahead and get started on that right now, and we'll be done with it. Okay, got that function already input in my calculator, so we can go ahead and do the same thing we did before. Okay, feel free to fast forward to the very end to see if you got the right answers. Okay, so if we draw the graph, I'm already in that window that I had for the last problem, so this one is an easy one because the window's already in the right place. And so we can draw the graph looking like that. We can find that minimum value, second calculate min, a left bound of 0.1, a right bound of, again, 150, and a guess of, let's say, 100, and we get our minimum value of 38 where the minimum value is 38.161. The minimum value is 1,431.64. So because what we're really doing here is we're finding a cost, so we'll round to the nearest penny. And let's see if I can do this here. No, I'm not going to be able to. So we have an absolute, again, absolute min value of, now I can put it up there, $1,431.64. Okay, and that's at x equals 38. Now I know this is the number of bicycles per day. See, if you wanted to leave it at 38, that would be fine, but if you really like to round, you can do that as well. 0.161. I'm not concerned about that. That you understand how to get that value is more important. And again, we have no x-intercepts and we have no y-intercepts. And so that's it. Hopefully that clarifies things. If you have this all completed on Monday, you'll get full credit for your homework. And that's the only homework assignment that I'm going to have you guys do this weekend. So have a great weekend, and I'll see you Monday.